The objective of this lesson is to teach you how to set up a basic web server on the ESP32 microcontroller. By the end of this lesson, you will be able to write code that allows the ESP32 to serve a simple HTML web page. This will lay the foundation for more complex IoT web-based applications, such as real-time data monitoring. In the previous lesson, we have successfully connected the ESP32 to a Wi-Fi network. Now we will be taking advantage of that connection by hosting a server directly on the ESP32. A web server is an application that serves web pages to users when requested. In IoT, hosting a web server allows devices to share information, display data, or even receive commands via web browsers. Imagine visiting a web page that shows live real-time sensor data directly from the ESP32. Well, this is exactly what we're going to be doing in this lesson. This is a critical skill for any IoT developer because it allows data to be shared and accessed remotely in real time, opening up numerous possibilities for remote monitoring and control. So, what is a web server? A web server is a program that listens to incoming HTTP requests and responds to them by serving HTML pages, files, images, or data. In the case of IoT, the ESP32 can be used to serve lightweight web pages or data directly from the device. The ESP32's ability to act as a server is a powerful feature that allows it to provide real-time data to any other device on the same network. By hosting a web server, you can monitor and control your IoT device using a web browser on your smartphone, PC, or tablet. Let's start by writing the code for a simple web server. We will be building on the previously written Wi-Fi connection code. webserver.h library. After that, here where we preset our variables, we're going to create a web server object. Create a web server object. This will be done by using web server, server, and then 80, which means that we are creating the web server on the HTTP port. Until now, we only use the void setup and void loop functions. Now we're going to create a new function called void handle root. First, we're going to start by defining a basic HTML page as a string. To do that, we will be using string HTML page. We're going to put the quotation marks because it is a string. In here, we will be putting all of our HTML arguments, like opening up HTML, opening up body, and opening a header 1 being the size of the header. Our title will be Welcome to my ESP32 web server, and we will of course close the header. Now we will be adding a second line that will make part of the same HTML page by using plus and equal. We're going to create a paragraph here using P. This is a basic web server hosted on the ESP32. We're going to close the paragraph. We're going to close the body. And we are going to close the HTML. Great, this was all of the code that we needed to create the HTML page. Now let's work on sending the HTML response to the client. To do this, we will simply use server.send 200, which means that it is okay, text /HTML, and of course the HTML page that we have just created. Great, we have now finished our new function, the handle root function. Now it is time to set up the web server handle. We will be doing this in the setup after all of the Wi-Fi has been initialized. So let's document it, set up web server to handle requests to the URL. So we will of course write server.on quotation marks / and the handle root that we have just created. This will make it so every time that you access the IP of the ESP32, it will redirect to the web server and will serve the HTML page that we just created. Now let's actually start the web server. We do this like we would do any other library with server.begin. And of course we want feedback on that, so let's do a serial print and have it say web server started. Amazing. Now we only have to call in the server dot handle client function. Our web server is completely set up. Remember to implement the handle client directly into the loop function. After that, the handle root function defines the HTML content that will be served when the root URL of the ESP32 is accessed, which means the IP address of the ESP32. In this example, we create a basic HTML string containing a heading, h1, and a paragraph, p. After that, the server.send function sends an HTTP response to the client. The 200 is an HTTP status code. 200 means OK, indicating that the server request was successful. Text/HTML is a MIME type. A MIME type stands for Multi-Purpose Internet Mail Extensions, and it indicates the nature and format of the document, file, or assortment of bytes. In our case, the text/HTML means that the content is an HTML document. And of course, the HTML page is the variable that we have just created up here. In the setup function, the ESP32 connects to the Wi-Fi network. Once connected, the IP address of the ESP32 is printed out to the serial monitor, allowing you to access the web server. Then the webserver.on function sets up the web server to call the handle root function, where the root URL is accessed. The server.begin function starts the server, making it ready to listen for incoming HTTP requests. And lastly, in the loop function, the server.handleClient function continuously checks for and responds to incoming client requests. When a request is received, it triggers the handle root function to serve the HTML page. So again, to test the code, you upload it, and then you monitor the output in the serial monitor. Now that it has been successfully uploaded, let's reset the ESP32 and check for the details. It has successfully connected to Wi-Fi, we successfully received the IP address, and the web server has started. Now we take the IP address, we go into a web browser on any device connected to the same Wi-Fi network, and in the browser's address bar, you enter the IP address of your ESP32. You press enter and you should see the HTML page with the heading, "Welcome to my ESP32 server." Congratulations! Now that you have successfully hosted a web server 32, let's explore what's happening. When you type the ESP32's IP address into your web browser, it sends an HTTP GET request to the ESP32. The ESP32 receives the request and calls the handle root function. Then, the handle root function generates an HTML response, which is sent back to the browser. The browser then renders the HTML page, displaying the content provided by the ESP32. This demonstrates how the ESP32 can act as a server, providing web pages in response to clients' requests. While this example serves a static HTML page, further lessons will teach you how to make these web pages more dynamic, allowing them to display real-time sensor data. You can experiment with modifying and customizing your HTML page by modifying the HTML code in the handle root function. Try adding more HTML functions such as images, links, or additional text to practice serving richer content. For example, we can break these apart. Now we can also include a new paragraph containing a link, for example. And of course, do not forget to close it. Now if we upload the code, we will see the changes done. This modified code includes a hyperlink in the web page. You can experiment with different HTML tags to make your web server more interactive. Now that it has finished updating, let's check out the new result. Great! In this lesson, we have successfully set up a web server on the ESP32. It serves a simple HTML page when accessed from a web browser. This is a powerful step forward as it allows you to interface with your IoT device remotely via a web interface. The ESP32 can now act as a central hub that communicates with users or other devices on the same local network. In future lessons, we will build on this web server by adding dynamic content, such as real-time sensor data from your IoT project. But for now, you have taken significant steps towards mastering the integration of IoT devices with web technologies. Good job!